Welcome to this session on business mathematics. Our today's topic is ratio. Hello, my name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. This is a brief outline of this session. I have divided this course into two modules. In the first module, we will see about introduction to ratio, types of ratios, and what are the problems that we have in ratio. In the next module, we will discuss about dividing a quantity into a given ratio and writing two or more ratios in a single form. We will also see some numerical and word problems. So let's begin this first module. Ratio is basically a comparison. We can say that ratio is a quantity which represents a relation between two quantities of the same kind by division. For having ratio, it is a requirement that both the quantities should be of same type or same kind. It is a comparison which explains to what extent one quantity is greater or smaller than the other one. The ratio between two quantities can be expressed in two forms. First, by subtracting or taking a division of one quantity from the other. If the difference is greater than 0, that is positive, we can say that the first quantity is greater than the second quantity. Now, if the difference is less than 0, that is, we have a negative value, we say that first quantity is less than the second quantity. If the difference is equal to 0, we say that both the quantities are same. Let us take an example. For example, in a class, there are two boys. The height of first person is 175 centimeters and the height of second person is 173 centimeters. Now, if I want to compare the height of both the people, what I do, I subtract the height of second person from the first person. Since the height of first person is 175 centimeters, which is more than the second one, if we take a difference, the answer is always more than 1. So we conclude that the first quantity is greater, or in this sense, we say that the first person is taller than the second person. Now, if we take a difference of the second quantity to the first quantity, that means if I subtract the height of first person from the height of second person, the answer is negative. So we conclude that the height of second person is less than the height of first person. Now, if both the height are same, then the difference is equal to 0. This is the first method in which we compare two quantities by taking a subtraction or division. This is the first kind of comparison in which we take subtraction or difference of two values. Now, in second method, what we do, we will take a division of one quantity by the other. For example, I have a quantity like I measure the height of a person in feet and I can also measure the height of a building in feet. Suppose the height of a person is 6 feet and the height of building is 60 feet, that is 60. Now, if I take a division of first quantity by the other, that means if I divide the height of a person with the height of a building, my answer is 1/10. So I conclude that the height of a person is 1/10 the height of a building. Now, in other case, if I divide the height of a building with the height of a person, I can say that 60 divided by 6, the answer is 10. So I conclude that the height of a building is 10 times the height of a person. In real life situations, comparison by using division makes sense because there are certain parameters which we can measure on the same scale, but to compare them is not very good. For example, I can measure the height of a person and I can also measure the height of a Mount Everest on the same scale. But it is not wise to compare height of a person with the height of Mount Everest because this division or this difference is too large. So in such real life situations, we make use of ratios. For example, an architect wants to draw the drawing of a building. What he does, he just draw the building on the piece of a paper by taking a suitable scale. That means on his graph or his paper, 1 centimeter is equal to 10 feet in actual building size. So this is called scale drawing. For this, we make use of concept of ratios. In certain real life situations, division by using comparison is a good method that makes a better sense. Let us look at the definition of ratio. Ratio is a relation in which one like quantity bears to another quantity of the same kind with regard to their magnitude or value. The comparison is made by considering what multiple part or parts one quantity is to the another quantity. Here, the first quantity is called antecedent and the second quantity is called consequent. It is also known as first term and second term respectively. Ratio gives information of how much one thing is there as compared to the other thing. For example, there are 4 boxes here, 3 of blue color and 1 of yellow color. So I can say that there are 3 blue boxes as compared to 1 yellow box. That means the ratio between blue and yellow boxes is 3:1. In other way, I can say that there is 1 yellow box as compared to 3 blue boxes. Now the ratio between yellow and blue box is 1:3. Please note here that 3:1 is not equal to 1:3. Ratios can be shown in different ways. First, we can use a colon symbol, that is to separate the values, 3:1. Second, we can use the word 2. That means I can write it as this is ratio of 3:1. In third case, I can represent ratio as a fraction. That means 3:1 can be written as 3/1. Ratio is preserved if we multiply or divide the ratio numbers by the same value. Let us take an example. Here we have 8 boxes. 6 boxes are of blue color and 2 boxes are of yellow color. So what is the ratio between blue and yellow boxes? The ratio is 6:2. According to this property, on dividing each value of 6:2 by a common divisor, that is 2, I get a ratio as 3:1. And if I multiply each value of 3:1, I'll get a ratio of 6:2. That is, ratio is preserved if we multiply or divide the ratio numbers by the same value. Now we see part to part and part to whole relationship. Ratios are used to represent this part to part and part to whole relationship. Ratio between two like quantities, say A and B, can be written as A:B or A/B. Now let us take an example. There are 5 students in a class, of which 2 are boys and 3 are girls. To represent a part to part relationship, we can say that the ratio of boys to girls is 2:3, since we have 2 boys and 3 girls, and we can write it as 2/3. Similarly, the ratio of girls to boys is 3:2, that is 3/2. Now we see part to whole relationship. Part to whole means the ratio of a single quantity with respect to the whole number of quantities. Here the ratio of boys to all students of the class is 2:5, as we have 2 boys in a class of 5 students, or I can write it as 2/5. Similarly, the ratio of girls to all students in a class can be represented as 3:5, that is 3/5. Now we see types of ratios. There are many types of ratios depending upon the type of relationship they represent among the values. The first type is less inequality ratio. This is a ratio in which if the ratio between two quantities, say A and B, is less than 1. Here the consequent part is more than the antecedent part. That means the denominator is more than the numerator. For example, we have 4/5, 1/17, 8/19, and so on. What is important here is that if you divide the ratio in terms of fraction, the answer is always less than 1. Second, the greater inequality ratio. If the ratio between two quantities, say A and B, is more than 1, we say that it is a greater inequality ratio. Here the antecedent part is more than the consequent part. That means the numerator is more than the denominator. For example, 5/2, 17/7, 29/3, and so on. So if we divide it in terms of fraction, the answer is always more than 1. Next, equality ratio. As the name suggests, it says that the two values are equal. So if the ratio between two quantities is 1, we say that it is an equality ratio. Here both antecedent as well as the consequent have the same value or are equal. For example, we have 5/5, 10/10, 17/17, and so on. Here the ratio between these two quantities is always 1:1. Next type of ratio is inverse or reciprocal ratio. The ratio of reciprocals of A and B is said to be reciprocal ratio. Here the antecedent and consequent of one ratio is the consequent and antecedent of the another ratio. For example, we have A/B. I can write it as 1/A divided by 1/B. So it turns out to be B/A. Such type of ratios are called inverse or reciprocal ratio. The next ratio is duplicate ratio. The duplicate ratio are of 4 types. Let us see how these points are. We have 4 types of duplicate ratios. Let us see them one by one. Now here, first is called duplicate ratio. A duplicate ratio is a ratio in which we take a square of the ratio of the antecedent and a consequent. For example, we have 2:3. Now if we take a ratio of square of 2 with the ratio of square of 3, I say that it is called duplicate ratio. So square of 2 is 4 and square of 3 is 9, hence our ratio is 4:9. The next ratio is subduplicate ratio. A subduplicate ratio is the ratio of square root of an antecedent and a consequent. Let us take an example. We have again 2:3. Now if we take a ratio of under root of 2 with under root of 3, that means 2 raised to power 1 by 2 is to 3 raised to power 1 by 2. This is called a subduplicate ratio. The next ratio is triplicate ratio. Here we take cube of a ratio of an antecedent and a consequent. For example, we have 2:3. If we take a ratio of 2 cube is to 3 cube, that is 8:27, we say that this is a triplicate ratio of 2:3. The next ratio is subtriplicate ratio. Here we take ratio of cube roots of an antecedent and a consequent. For example, we have the ratio 2:3. If we take a ratio of third root of 2 with third root of 3, that is 2 raised to power 1 by 3 is to 3 raised to power 1 by 3, this is called subtriplicate ratio. The next type of ratio is continued ratio. If 3 or more quantities like A, B, C and D are to be compared by division, they can be written as ratio, that is A is to B is to C is to D. In expanded fraction form, it can be written as A upon B is equal to B upon C is equal to C upon D. This is called continued ratio. The next ratio is compound ratio. Here, the ratio of products of all first terms with the products of all second terms is called compound ratio. For example, we have ratios A upon B, C upon D, E upon F. Here, none of the parameters are repeating. So, the compound ratio of this is, we have to multiply all first terms, that is A into C into E, with the ratio of all product of second terms, that is B into D into F. So, we have ACE is to BDF. This ratio is called compound ratio. After types of ratios, now we come to properties of ratio. The first property of ratio is that the ratio of two like quantities can always be determined. If we have two quantities of the same type that can be measured in terms of same units, or it can be converted from one unit to the other so that the unit or type of both can be same, we can find ratio between these two quantities. Second, in the ratio of two quantities, the order is significant. Okay, that means we can say that the ratio A is to B and ratio B is to A are different, except that the value of A is equal to B. For example, we have 5:2 and 2:5. These two are different ratios unless we have both the ratios same, that is 5:5 or 2:2. The next point, the ratio of two quantities can be expressed as fractions. If the ratio between two quantities is A is to B, we can write it as a fraction A upon B. Here please remember, all ratios can be expressed as fractions, but the reverse is not always true. That means we cannot always represent fractions as ratios. Let us see how and why. For example, we have a relation as speed is equal to distance upon time. Now we can write it in terms of fractions like distance upon time, but we cannot write it as distance is to time. Why? Because for ratios, the type of the quantities should be same. Here distance and time are both different entities, so we cannot represent this fraction as a ratio. This type of fractions are known as rates, or we can say that speed is nothing but rate of change of distance with respect to time. So these are represented as fractions only, and they cannot be represented as ratios. Ratio remains unaltered if its antecedent and the consequent are multiplied or divided by the same number. For example, we have a ratio A is to B that can be represented as a fraction A upon B. Now, if I multiply each value by 2, that is 2 into A divided by 2 into B, my ratio doesn't change. Also, if I do A upon 2 and B upon 2, the ratio still remains the same. Hence, we say that ratio remains the same if its antecedent as well as its consequent is multiplied or divided by the same value. The next point, ratio of two like quantities is only a numerical value. It does not have any units. We don't have any units of ratios. Next, ratio is always written as smallest fraction of quantities. We always represent ratio in the minimum possible fractions. Take an example. We have a ratio 25:30. I can write it as 5 into 5 is to 6 into 5. Now here 5 and 5 both are common in both, so I divide it by 5 from numerator as well as from denominator. I get the ratio as 5 is to 6. This is the smallest fraction or smallest ratio I can represent the given ratio. Hence we say that ratio is always represented as a smallest fraction. Next, if same quantity is added to the antecedent and the consequent, then the greater inequality ratio decreases and the lesser inequality ratio increases. Let us understand what is written. For example, we have a ratio 5 is to 2. Now on adding 1 to both the sides, we have 5 plus 1 6 and 2 plus 1 3. That means my ratio is 6 is to 3. But since we represent ratio as a minimum fraction, so I divided by 2 both the sides, so I'll get the ratio as 2 is to 1. Now if I divide it in terms of fractions, first I divide 5 by 2, my answer is 2.5. But when I divide 2 is to 1, that is 2 by 1, my answer is 2. That means this decreases. Hence the greater inequality decreases. Also, if we have a ratio 2 is to 5, on adding 1 to both the sides, we have 2 plus 1 3 and 5 plus 1 6. That is, the minimum ratio is 1 is to 2. Now if I divide 2 by 5, my answer is 0.4. If I divide 1 by 2, my answer is 0.5. Thus, this lesser inequality ratio increases. The next point, if same quantity is subtracted from the antecedent and the consequent, then the greater inequality ratio increases and the lesser inequality ratio decreases. Let's take an example. We have a ratio 5 is to 2. On subtracting 1, we have 5 minus 1 and 2 minus 1, that is 4 is to 1. If I divide it by 2, I'll get the answer as 2.5. And if I divide 4 by 1, I'll get the answer as 4. That means this increases. Now if we have a ratio 2 is to 5 and on subtracting 1, we have 2 minus 1 and 5 minus 1, that is 1 is to 4. If I see the trend, here we divide 2 by 5, my answer is 0.4. And if I divide 1 by 4, my answer is 0.25. Hence, this lesser inequality ratio has increased. Ratios are always represented in full figures without decimal, which makes a fraction, although they can be represented or written in a mixed fraction form. For example, we have 7 is to 3. I can write it as 7 by 3, or in mixed fraction, I can write it as 2 1 upon 3. Now let us look back what we have covered in this module. We started with what is ratio, we have seen the concept of ratio, we have seen how we represent ratios, we have seen various types of ratios, and also we looked upon the various properties of ratio. I hope this has given you some insights on this topic of ratio. In the next module, we would be covering topics like problems in ratios, how to represent a ratio in terms of another ratio, how to divide a given quantity in a given ratio, how to write 2 or more ratios in a single form, and we will see some word problems and numerical problems on ratios. I hope this session would be beneficial for you and you will learn the concepts of ratio in a better manner. Thank you.